Hello everyone. So in this particular session, we'll be writing a C program to add two integers. And then with that, I will be introducing the concept of tokens in C programming language. Okay, so let us write this program first of all. So the first line is hash include stdio.h and then integer main. So every C program begins its execution from main function. And this main function does not take any parameter. So the parameter is void over here. Now we'll take two integer. So integer n1, let's say some integer like 18, and n2 is let's say some other integer, let's say 21. And I'll take an integer variable r, n1 plus n2. So do not worry about the concepts that I'm saying right now, variables, constants, and so on, because in the subsequent discussions, I'll give clarification regarding this thing. Through this program, I just want to give you a demo regarding this token. Now here I'll print out printf percentage %d slash n, and I'll print the result for this r. Now, so I'll compile this one, the C compiler name, and the source file name is hello.c, and output I want it with the name hello. Once the compilation is successful, now in order to execute dot slash and the executable file name. And you can observe the sum of this 18 and 21, that is 39, is printed as the output. Right. Now, through this program, I want to introduce you to the concept of tokens. So here, our next module comes into the picture, that is data types, operators, expressions. And this forms the foundation of any programming language, even for C, right? So variables, constants, declaration of the variables, operators, then expressions. So these are the building blocks of any programming language. Now, in order to understand these building blocks, we need to understand the basic element, that is token. Just like any human language or natural language such as English, the words can be categorized into noun, pronoun, adjectives, adverbs, and so on. Similarly, you want to check that if you are writing any word, so in which category of token that particular word falls in. So some of the examples of tokens that I can say is that it could be identifier, like you can observe here, it is an identifier n1, then we have integer literal, then the operator plus, and then we are having string constant here written within the quotes, right? Then we have the separators or the punctuators like braces, and then parenthesis, and then we have a statement terminator like semicolon. So all of this falls under the category of tokens. So for tokens, we can say that tokens are the fundamental building blocks of a program's grammatical structure. Just like for spoken languages, for their grammatical structure, we have parts of speech. In the similar way, we are having tokens when we are talking about a programming language, right? So a token is nothing but it is a sequence of characters to be treated as a single unit. For example, here, this integer is a keyword. If I break it by a space, and in that case, if I try to compile this program, so in that case, my compiler won't be able to understand and it will throw error like this. So in order to understand this error in an efficient way, we need to understand the concept of token. That means my compiler, in the compiler, within the compiler, I have a software called lexical analyzer. My lexical analyzer considers this integer as a keyword. So the moment you put a space over here, now it cannot identify whether it is a keyword or it's an identifier or what it is. So in that case, you're getting error because it is violating the syntax and semantics of the C programming language, right? So now examples of tokens. So like in our natural language, like in the English dictionary, we have the vocabulary, right? That is a collection of words. Similarly, for a programming language, we have collection of words, we call it keywords. So keywords are the reserved words or special words which has special meaning to the compiler. And we cannot use keywords for any other purpose except for its own definition. Then we have the operators. Like in this program, I have used the plus operator to add two numbers. Then we have used this assignment operator to assign values to the variables and so on. Do not worry if you are getting any kind of confusion regarding the terminology, because in our subsequent discussion, we'll give clarification regarding this thing, right? Then we have identifiers like variable names. In this case, you can observe n1 is the variable name. So for this variable name, the data type is integer. That means this variable is going to store integers, right? So whenever any programmer has to put a name separately, programmer defined names are called identifiers. So variable names, array names, procedure names, function names, structures, unions. There are a lot of other programming constructs where programmers need to define their own names. So for that case, we have identifiers, and there are certain rules for identifiers, which we will discuss in the subsequent lectures, right? Next is the constant. So if you observe 18, this is the integer constant. If you show this to any person who has fundamental knowledge of mathematics, they can definitely understand that it is 18. So globally, it is 18 for everyone. So constant is something that is fixed and cannot change over time, right? So we have numerical constant, string constant, like we have written this particular string within the double quote, or if you remember the hello world program in which we have written hello world within the quotes. So these are your string literals. Then characters. So character constants are there, then Boolean constants and so on. So these are all of these, even the punctuators or the separators, all of this comes under the example of tokens, right? So the C programming language distinguishes the lexical structure, that is the punctuators or the separators, identifiers, that is also known as the programmer defined names, the numbers, constants, right, operators. So all of these are the part of the lexical structure of the C programming language. The grammatical structure, that is the syntax. So syntax is framed out of these tokens, right? And the semantics, that means whatever syntax is written, something that is syntactically valid may not be valid semantically. So that is there, and we will understand this in our upcoming discussions as well, right? So finally, I can say that a token is a minimal lexical element. That means you cannot break it further. I mean to say, you cannot give a space between this. It is int is a keyword. If you try to break that one, definitely you're going against the you're violating the language rules, right? Now the category of tokens are keywords, that is the reserved words for any programming language, identifiers, constants, string literals, and punctuators. Now, according to the the de facto textbook, that is the C programming language written by KNR, there are 6 classes of tokens: identifiers, keywords, constants, string literals, operators, and other separators, right? And these are separated via white spaces. So the compiler determines which one is identifier, which one is keyword, that is by the white spaces. For example, between this int main, if I do not give a space, then my compiler cannot understand that which one is integer and which one is the identifier name. So that's why white spaces in some of the places are essential, right? Now, the input stream, that the program that which is given to the compiler, it is broken, it is decomposed into tokens. Now, as per the modern standard, the tokens are categorized as keyword, identifier, constant, string literal, punctuator. Even the operators also comes under this discussion of punctuator as per the modern standards. Now, here, this one I have taken from the Ullmann's textbook. If you can observe this lexical analyzer, it is also called as the tokenizer. So this is a statement written in high-level language like C, where we have position, assignment, initial, addition, operator, and then rate and multiplication operator, and then we have a constant 60. So which one is constant? Which one is identifier, which one is separator, operator, keyword? So this identification is done by the lexical analyzer, also known as the tokenizer. So position is the identifier, so therefore ID1 is mapped, if you can observe here, right? Then next, this assignment is the operator, so this is treated as a separate unit. Initial, this is the identifier, so this is the second identifier. Then plus, this is the operator, so here it is treated separately. Then rate, this rate is the identifier, so this is identifier 3. And this multiplication operator, which is a binary operator, this is treated as operator, again this is taken as a separate token, right? So this tokenization is done. That means, like just like in English language, which one is noun for a English sentence, let's say which one is noun, which one is pronoun, which one is adjective. So like that, tokenization is done. That means for every individual token, categorization is done, that which one is identifier, which one is keyword, which one is operator, which one is separator, and so on, right? So this was the basic idea regarding our tokens, right? So I hope it is clear. And if you observe this particular program, so here, if you observe this int is keyword, this main is identifier. Again, if you observe this parenthesis, this comes under the category of punctuators. The other name of punctuator is separator. Then void is a keyword. Then this braces, if you observe at line number 3 and line number 7, this brace comes under the category of separator. Now, if you observe this particular line, again, int is a keyword which represents a data type, which we'll discuss further. N1 is the identifier. So this is programmer defined name. I can put any name. So any name, but I have to follow the rules of identifier, right? So here for now, I'll write N1. And then this is the assignment operator. This is the integer constant, right? And similarly, you can explain it by yourself, this particular line as well. This is the comma, right? Separator. And this semicolon, this is the statement terminator. Like in English language, the full stop is the end of a statement. Similarly, we end the statements in C language by semicolon. And again, you can observe there is a variable declaration, that is int keyword, then R is the identifier name, operator. This will add two numbers, N1 plus N2, whatever is the result. That result will be stored in this R with the help of this assignment operator. Next, printf is a library function which is whose declaration is available in the header file stdio.h. And then you can observe within the parenthesis, we have this string here. It is also called as the format string, but for now we can say string literal. And then we have comma, which is the part of punctuator again. R is the identifier. This parenthesis is the separator, and semicolon is the statement terminator. So I hope the identification of the token is clear to everyone. Thank you.